Let's focus on the red car in the scene and observe how it is being tracked. The first row displays the tracking performance of CASTRAC using VirsioNV and CAS detectors. The second row shows a side-by-side comparison with our framework, RobMOT, employing the same detectors. Notice that the red car is assigned ID 85 by CASTRAC with the VirsioNV detector at the top left. However, due to an occlusion, the red car ID has been incorrectly associated with a white car. Meanwhile, the red car is identified as a new car with ID 99. Indicating that the track of the car was lost after the occlusion. On the other hand, our framework, using the same VirsioNV detector, recovers the track of the red car after the occlusion without any misassociation or ID switch. Let's shift our focus to the gray car located behind the white van. CASTRAC identifies this car as ID 4 with VirsioNV detector and ID 20 with CASA detector. However, our framework assigns a different ID to it, ID 3 with VirsioNV detector and ID 40 with CASTRAC detector. The gray car is only visible for a short period of time before being hidden by the white van. After the occlusion, CASTRAC loses track of the car in both VirsioNV and CASA detectors, assigning different IDs to it. In contrast, our framework continues to track the car in both detectors, as demonstrated in the bottom row.
In this scenario, we highlight the existence of trajectory drift in the recent benchmarks caused by noise from the detection and how our approach mitigates the noise, enabling precise state estimation during occlusion. Let's observe the bounding box of these two cars pointed by the red and blue arrows. Notice that the cars will be occluded by a blue van coming from the opposite side. Look at the bounding box of the car with ID 4 in CASTRAC at the top left. The bounding box is moving down during the occlusion. However, the bounding box shouldn't have moved since the car with ID 4 does not move. You can see our framework using either VirConv or CASA detector shows a robust trajectory of the car during the occlusion without being deviated, as what happened with CASTRAC at the top left. On the other hand, CASTRAC with CASA detector lost track of the car by assigning a new ID, 18, rather than 3 which was previously assigned. This part highlights our tracking performance, focusing on how our scoring formula effectively distinguishes between accurate and false, ghost, tracks. This formula plays a crucial role, assigning a confirmed status to tracks that maintain reasonable detection scores over time and short periods of absence. It uses this information to calculate a confirmation score for each track. When this score crosses a certain threshold, the track status changes from not confirmed to confirmed. Notice the car with ID 0. It delivers only 2 measurements before exiting the scene. Ordinarily, one would expect a significant divergence in its trajectory due to the limited observations. However, our noise mitigation approach still decreases the impact. With an adequate number of measurements available for each track, our mitigation approach facilitates precise long-term trajectory estimation. This is exemplified in the cases of cars with IDs 13 and 1, as showcased here. The accuracy of our system in projecting the trajectory state estimation over an extended period is clearly observable. In this instance, observe how an actual car, assigned ID 41, is confirmed by our scoring formula. This confirmation is a result of the formula recognizing the track's legitimacy. In contrast, track 45, located adjacent to the car, remains unconfirmed, marked by a low score, signaling its status as a likely ghost track. Shifting the focus to the right side of the screen, notice 2 tracks corresponding to actual cars with IDs 39 and 44. These tracks exhibit an increasing confirmation score over time, suggesting their validity and diminishing the likelihood of being ghost tracks. As time progresses, you will see these track statuses are eventually updated to confirmed. You may observe that each track's bounding box includes a small centroid box. This box is color-coded for quick reference. Green indicates the track has received a new measurement, while red denotes an absence of new measurements. This could occur due to occlusion or the track leaving the scene. Pay particular attention to the distant car labeled ID 41. Despite significant occlusions and its far range, our tracker consistently maintains tracking over time. This demonstrates the exceptional performance of our tracking approach in challenging conditions. Thank you for your attention.